So in this video, I want to explain the order of transformations. So when you learn about transformations, you learn about reflection, you learn about stretch compress, and you learn about shifting or translation as well. So why is the order to reflect first, then stretch, then translate? Or does a different order work? And we're going to go over that in this video. I'm making a dedicated video for this so that I can give it to my students instead of referring them right now to the middle of another video where I explain this. Okay, so let's go over why this is the case. And to be honest, when I first learned transformations, they never taught me this order. And even if they did tell me to first reflect, then stretch, then shift or translate, why is it like that? So I'm a firm believer that if you understand why, then it's much easier to memorize the order. And if you forget the order, if you truly understand it, you can go back to think it through of why the order is like this. Okay, so let's motivate with an example. Let's start with the exponential function 2 to the x. It looks something like this. Okay, 2 to the x minus 1, that's a shift down by 1. So it's the blue looking curve over here. This is the parent function 2 to the x. This is the one that's shifted down by 1. Negative 2 to the x, this is a reflection about the x-axis. Okay, so now what we have a combination of both shift down by 1 and reflect about the x-axis. So let's take this function negative 2 to the x minus 1. Again, if we just pick out the pieces of the transformations, it looks like it's getting shifted down by 1 and it's a reflection about the x-axis. So which one do we do first? So this is what happens when you reflect first and then shift. You would get this curve over here. Again, this is the parent curve, not e to x, 2 to x, and this is the minus 2 to the x minus 1. Okay, this is correct. And we can even quickly check when x equals 0, we get 2 to 0, which is 1. So minus 1 minus another one, that's negative 2, minus 2, which is what we have on the graph over here. So that's correct. What happens if we had shifted first and then reflected? So we would get this type of graph instead, which is not right. Again, we plug in x is 0. We get negative 1 minus 1, which is minus 2. That's not what we have on this blue curve. We have our y value to be 0 when x is 0. So something went wrong. So why do we have to reflect first and then shift? Okay. So honestly, this is what one of my students taught me when they first learned it. Their teacher taught them to memorize this acronym, RST, to reflect first, to stretch next, and then to translate or shift last. Okay? So if you like acronyms, this is hopefully a good one to remember. It's pretty simple, RST. So now let's try to understand why we have to reflect first, then stretch, then translate. Actually, to be more precise, it doesn't matter the order of reflect and stretch. As long as they happen before you translate, that's totally fine. So you can do SRT as well. Okay, so now let's understand why you want to reflect and stretch first. It all comes back to order of operations. So if you remember your order of operations, you have to multiply first before you add or subtract. Multiplication has to happen first. So let's take a concrete example, like minus 3 times 2 to the x minus 1 over here. Okay? Like if we want f is 0, what do we do first? We first evaluate the exponent, right? 2 to 0 is 1. That's what happened right here. Okay? Then we got to multiply first. So this minus 3 times 1, that's negative 3. And then we finally do the subtraction. So it's negative 4. Okay? So if we think in the perspective of order of operations, it makes total sense why we have to reflect and stretch first. Reflecting and stretching is the multiplication portion, that's minus 3. We did that first in the order of operations before we did the -1 over here. Or we multiplied by -3, I should say. So again, reflecting and stretching is the multiplication portion, and the shifting is the addition or subtraction portion. This explains why we reflect and stretch first. So I'm going to take this function, -3 times 2 to the x minus 1, and I'm going to go through all possible combinations of orders. So this total of 6. We're going to go through. So we have like RST, we have RTS, SRT, STR, all the combinations, all 6 of them. So I'm going to show you what happens, okay? This is the correct way, RST first. So we take the parent function, 2 to the x, this one right here. I try to match the colors. If we first reflect it, it's this one right here. We stretch it vertically. So now it's this one over here. When you stretch it vertically, it looks like more compressed horizontally. You remember this kind of an inverse relationship. And then we translate that this black one over here. Okay? This is the order that's happening over here. So what if I had reflected first, then translated, then shifted? It looks like this. So from the parent, we reflect first, that's right here. Then we translate, we shift down to this blue one over here. And then now we stretch. It became this solid black curve over here. However, this dashed black curve is what's actually correct, what we had in the previous slide. Okay. Now we look at the algebra of what happened. 2 to the x, we reflect, so we multiply by -1. Okay. We translate, so we subtract 1 from the whole thing from the previous step, so -2 to the x, and then we subtract 1 from the whole thing. We stretch, so we take the whole thing from this step, -2 to the x minus 1. We take the whole thing and multiply it by 3. So if we distribute this 3, we get -3 times 2 to the x minus 3, which is clearly not the same as the original function. That's why they're different. So you can see from a graphical perspective how they're different, and the reason is from the algebra over here. Okay. Similarly, oh, actually, this is SRT. So remember I was saying, doesn't matter if you reflect or stretch first, as long as it happens before you translate or shift. So you could either do RST or SRT, doesn't matter. Let's look at the math of y. So we stretch first, we multiply the whole thing by 3. Okay. Now we reflect, we multiply the whole thing by -1. That's why there's no difference. You're multiplying. The stretch and reflect, you're both multiplying. So it doesn't matter the order. Okay. Now, as long as you do those before you translate, so you subtract the whole thing by 1, this is the same as the original guy still. Okay, so we still get this curve over here, the solid black curve. You don't see the dotted one because the solid one is on top of the dotted one. So that's how you know from if you actually graphed each step that you got the right answer. It perfectly lied on top of the dashed one. Okay. Now let's go over more incorrect cases. What if we had stretched first, then translated, then reflected? So we go through the math, stretch first and multiply the whole thing by 3. Now you translate, so we subtract the whole thing here by 1. And then we reflect. So we take this whole thing and multiply by -1. We go through the math, so we distribute this -1 to both terms. You would get this. Clearly, that's not the same as the original guy. And you can see from the graph, this is what we get. But then the actual answer is this dashed black curve. Okay. TRS, it's also not correct. We go through the math. If we translate first, we subtract 1. Then we reflect, so you multiply the whole thing by -1. And then we stretch, so you multiply the whole thing by 3. So not the same as the original. And you can see the graphs there. I'm not going to go over it one by one now. And lastly, TSR, you get the exact same curve as what we just did, but the math, the end equation is the same, but the steps in between look a little different, but it's still wrong. So hopefully this kind of explains why we have to reflect or stretch first before we translate. So again, I was never taught this when I first learned about transformation. So hopefully this can be of help, whether you're learning this for the first time or you're revisiting this topic because you just need a refresher or something like that. All right. Please give this video a like if it has helped you in any way, and hopefully see you in another video as well.